As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-through or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now.
Hello, everybody. It is my great pleasure to welcome Star Talk Live to the show, to AwesomeCon. Ladies and gentlemen, let me bring on your host, one of America's great science educators and communicators, Bill Nye the Science Guy!
Woo! Eugene, guy hug.
Hello.
Yes, good to see you.
Welcome.
Greetings. Woo! Wow, look at you guys. Greetings. I imagine this is not the first time you've heard this weekend. This is awesome. So speaking of awesome, should we introduce our guests?
Let's do it.
Well, start out, where should we start? We'll start over here. The most hilarious woman ever, and you know her by her Twitter handle, @KingFirestorm. Ladies and gentlemen, Jo Firestone.
Hello.
Next in this corner, or this chair, from the Astrobiology Institute, you know him by his Twitter handle, Dr. Funky Spoon. David Grinspoon. David.
Hey there. How you doing?
Good to see you, sir. Yes.
Good to see you too.
Then in this corner, which is a chair. And I'd give you his Twitter handle, but he said, no, just Google him. Hari Kondabolu.
Welcome.
Hari Kondabolu. And then lastly, everybody, somebody who really works in the business full time. The second in command at NASA, the deputy administrator, Dr. Dava Newman. Give it up. Here she is.
Hi, guys. Thank you, sir.
Oh, we'll do
Thank
this,
you.
and then this, we'll do this. Yes. Oh, we messed up our microphones. Look at it. There it is. Oh, please, everybody, please sit down. Are there any questions on what we've covered so far? No, we're at AwesomeCon. This is superhero time. And on stage here with me, I claim, are the superheroes of space exploration. So for me, what I'm hoping for is to have superpowers, right? Now, what do you guys want in superpowers? Main thing for me, I want to be able to fly. And then the next thing down that list for me is to be able to have extraordinary vision.
What would extraordinary vision? Like how far?
I'd like to see other planets.
Oh, okay.
Yeah. And then I'd like to have vision that would find life and stuff like that. So to get this started, Dr. Newman, you are an expert in aerospace and biomedical engineering. Yes. Your research studies include advanced spacesuit design and dynamics and control of astronaut motion, which is not trivial when you're in zero G.
Right, or Mars.
Tricky.
Uh-huh.
And you're the director of MIT's Technology and Policy Program.
On leave to serve NASA.
And as well as your deputy director at NASA. Now, Dr. Grinspoon.
Sir.
Of course, you're a regular here on Star Talk. That's why you're beloved.
Oh my.
And you are, I presume you are funky and you're good with a spoon. And that's why you're
my best.
Yeah, you're Dr. Funky Spoon. But right now you're the senior scientist at the Planetary Science Institute, right? Which is like an amorphous thing.
It's distributed.
Distributed because it's the modern world in which we now live. And you're a co-investigator on Mars Curiosity rover, right? And stuff like that.
This is right.
So here's the thing, you guys. I want to just ask you to start with, because we're at AwesomeCon. What would be your favorite, let's see, we'll start with David. What would be your favorite superhero?
So I'm going to combine a few. So it's Elastigirl.
You can do that?
Yeah, I'm going to do it. It's Elastigirl with Spider-Man, because the suit is cool. We came up with it first, for a suit for Mars. And I like to fly, too. So Batman, so Elasti-Spider, Batgirl. That's what I'm going with.
Yeah.
That's what I'm going with.
Cool. And
Batman doesn't really fly as much as he falls incredibly well.
Yeah. And he seldom gets hurt.
What was Elastigirl's? I'm not familiar. Elastigirl was just kind of bendy, or what was her thing?
Super bendy, cool.
Super bendy.
Nothing got in her way. Fast.
What was the difference between her and, say, Gumby?
Gumby, I think, is more Christian.
Oh.
Yeah. And green. Right. She's red. She's kind of more reddish.
Oh, so Gumby's green and she's red.
Right.
There.
Okay.
Just start with that.
Just start with that.
But seriously, you made an allusion to spacesuits that resemble superhero costumes.
There you go. But the technology came first, I think. Yeah.
The technology came first?
I think so. We've been working on the technology for a long time.
What technology are you talking about?
Advanced spacesuit design has to be, lightweight, mobile, flexible. We're going to Mars. Did you hear? We're going to become interplanetary.
We're going to Mars. We're not going to Mars during this.
Surprise, we're going to Mars. Pick a partner. I hope you're with someone you love.
Strap in.
Well, what are we doing in Mars? What are we doing? We're setting up shop, or what's happening there?
Well, we're already there. We've been there for the last 50 years with orbiters and landers, and the next 50 years are even cooler. We're going with people. So first we're going out. Space station, that's in low Earth orbit, phase 1. We've been doing this for 16 years together with the world. Then we move out to Earth, Moon in all the 2020s. Our rovers are still hanging out, doing Mars. We have these great experiments. We keep popping off the robotic missions to Mars. And then boom, boots on Mars with people in the 2030s.
This stuff will be there.
What's the year that you think that there'll be boots with people inside the boots?
People inside the boots in the 2030s. In the 2030s, but it's the 2030s, and it's probably not all of us, but it's the Mars generation.
Nice.
Is there
teenagers today.
Is there going to be commercial flights to Mars? Is that the plan?
Sure.
When does that start?
Government and commercial. So it's public-private partnership. And it's the world, too.
I heard Southwest is doing specials.
I can't wait till there's some weird line where you have to get into to get a Mars. To get your seat.
TSA.
Anyway, great Southwest joke. Terrible airline.
Watch out for the baggage charges.
Before we go too far along, David, you have a favorite superhero?
Yeah, I guess my favorite superhero is Planet Girl / Planet Boy, because
Planet Girl
/ Planet Boy because she's transgender and interplanetary, and she's got spectrometer eyes, multi-wavelength imaging spectrometer eyes, and she's got ion drives on her toes, so she can go in orbit around any planet and image just about anything you would want to.
Dr. Newman, you are the second in command at NASA. That's like a superpower.
It is super cool. I have the best job in the world. Maybe the second best. I think it's the best job in the world.
Can you ever go get out of here, go to outer space? A little?
Not out loud.
Because if you did, it would cost a lot of money.
But...
So when you say Journey to Mars, we spell that J2M?
I like that. That's a good acronym.
Is that right?
J2M. That's my shorthand for it.
And so in order to make the journey to Mars, let me ask you a couple things. What do we need to do?
We need a big rocket. So we're designing and developing, and this is real. Our space launch system is well under development.
How long will it take to travel from Earth to Mars?
So, round trips, about 8 months to get there, but just think of it as about a 2-year round trip in transit.
Right.
But hopefully we stay 600 days on the surface of Mars exploring.
And when you say 600 days, 600 Earth days, 600 sols?
Yeah, that's debatable. Let's say it's 600 Earth days, since I'm kind of counting in Earth days right now.
And 600 days is also just 600 days.
I think anybody who's ever seen the movie 2001 Space Odyssey would say, that is awesome. And part of the reason it was awesome, it was spinning, right? The space station is spinning, creating some artificial gravity. But right now, the proposal is to punch it and go to Mars fast enough, exercise enough on the way, and take the right medications to preserve bones.
See if we can preserve muscles and bones. Musculoskeletal, the bone, we lose, typically you lose 1 to 2% bone mineral density per month. Here on Earth, that's per decade. But maybe we have some small, you can do small short arm centrifugation that fits in the craft. That's a really interesting concept, like a spin in the gym. Imagine instead of the elliptical, could be a spinning thing. So we're still, playing around with the concept.
You would be in a spinning thing and it would...
Well, say the spacecraft, 2001, that was fantastic. Engineers love it, but that's expensive when you have a 2-kilometer radius, right?
Tell me about it.
So let's do a smaller one because, we have
like
great budgets, but we could spin inside.
Just a second, David. Just a normal blank? What? A normal what?
A normal spacecraft, normal Mars spacecraft.
A normal Mars spacecraft.
That's what I think about every day. And then we could have think of like little spinning beds inside. See, that's cool. That's still artificial gravity, but within the constraints of a normal Mars spacecraft.
So let's say that problem is solved. What is the biggest challenge?
The biggest challenge for getting people to become interplanetary, because we will become interplanetary. I hope sooner than later. That's what I'm working on. Biggest challenge is the will. Biggest challenge is the will.
To do it.
We have to focus, just deciding yes. The biggest challenge is just saying yes and getting all the people behind it say that, first answer why. Why are we going? They're the enduring questions. Are we alone in the universe? Is there life? Has there been past life? That's the why. Biggest challenge is let's just say yes and stay the course and don't get, derailed and just focus, and then we get there.
So that's the biggest challenge. Yes.
Well, give it up. Who's saying no to this? Like people that are afraid of aliens?
It's not no, it's just, apathy.
Who gets to own Mars? Like,
it has to be global. I mean, at NASA, we're saying, here's our plan. Here's what we want to lead. We have all of our elements, heavy lift launch, the Orion capsule on top. We get out, and then we're saying, world, come with us.
Even Estonia?
Sounds fine, Estonia, yes.
But sure.
Who wants to join? It's global. It's global exploration.
Isn't that a risk? Because that's the way colonialism worked before. Like all these different countries were going to a land and claiming it. So won't that just happen again with different companies and different
you think maybe we can get it right this time.
Ultimately, the Martians will probably own Mars.
Yeah, but we're going to kill them off. I discussed this earlier.
They could be.
We're going to become the Martians we're colonizing.
It could be really
when we go there, we'll be the Martians.
Sorry, really quickly, we're talking about Martians in this scientific form. They're real. What's happening?
Well, okay. Earth and Mars, 4.5 billion years, sister planets. Beautiful, wonderful. And we think, because we have a lot of scientific data now, Mars 3.5 billion years ago is probably wet, wonderful, maybe a little wild.
Back in the day.
3.5 billion.
Like Costa Rica?
And something
a little like Costa Rica?
Maybe. Costa Rica. And then something might have gone terribly wrong. Well, what went terribly wrong?
Too many parties.
Too many parties. We'd like to figure that out because that tells us a lot, again, about Earth, about spaceship Earth. And so if there's past life, it's probably kind of fossilized and, that's what we're looking for. Past life, probably.
So a couple things, though, literally. There is a space treaty from 1967.
Signed by John Lennon.
The wording of it is a little bit vague, of the space treaty, kind of deliberately, because it talks about going to the moon and other celestial bodies, like the Mars was a long way away. Nevertheless, Mars is getting to be within reach. It's getting to be a reasonable thing that people might do. And if we can really do this, my opinion, which as you know is correct, is that it's just not so easy to get to Mars. It's not like these guys came.
It's hard.
They came from Europe and they went across North America. They came from Europe, they went to South Africa, and they started eating things and setting up tents and stuff. But on Mars, it's a much more difficult deal.
Well, there's also a big difference, which is that there were people here when Europeans got here, and they weren't always recognized as people, and that caused a lot of problems. It seems as though there are no people on Mars, so the setup is inherently different.
But what about the protecting the role, let's say the objective to protect Martian life if it's found?
Yeah, well, that's one of our big scientific objectives now, of course, is to find out if there is Martian life so that we don't inadvertently do something really stupid to it.
So that along that line, we're sending robots, right? By robots, we mean spacecraft that land, drive around, cool tires, and to look for things. But how do we know that those things are sterile, those robots have been made clean enough to land there without contaminating the Martian life when we see it?
Well, we work on it. We take it serious. That's, in planetary protection. When we think about forward protection, we bring life. We're looking for life on Mars. Well, we sure don't want it to be our life. So we do that. And back contamination. So forward contamination. So it has to be, it's a whole area.
There's no way to know for sure. But it is taken seriously. We do our best. There are planetary protection protocols. We try to clean our spacecraft. We don't sterilize them 100%, but so we know we've brought some microbes to Mars.
When you say we don't sterilize them 100%, I will ask the obvious question. Why not?
Because it's very hard to, in order to sterilize a spacecraft, you would have to cook the whole thing to a point where you would destroy a lot of the scientific instruments. So
you'd melt the electronics.
So we kind of play this game where we get them clean enough so that we know how many microbes are on there, and we land them in places where we don't think those microbes would survive. It's a little bit of a game you have to play. So we know there are some microbes on Mars that we've brought there, but we don't believe we've started colonies of Earth organisms on Mars.
Because
I would love to beat everybody there and put a bunch of rabbits on Mars. And then you go like, oh my God, there's so many rabbits.
Wait, what are we looking for as far as Martians? Are we looking for like plants or worms or?
Fossilized, it's kind of like think about going to the beach and looking at those cool, fossilized shells. Kind of like that.
Like something like a mussel, like a seafood.
Harder and flatter and 3.5 billion years old.
So you're looking for what was there, not what is there.
Past life.
There's nothing there.
What is there? Well, what is there? We're finding out every day. We know how Mars lost its atmosphere. Our MAVEN observer just helped us figure that out. And we know there's methane. Mars is breathing, kind of saying hi to us with methane coming out. I think it might be active methane.
So when you find
methane from what?
Oh my God!
People lighting matches?
Yeah, we don't know. In fact, the existence of the methane itself is somewhat controversial, though. It's looking better and better. There probably is methane, and of course, a long time ago, before we found the methane, that was one of the things that scientists said would be a biosignature on Mars. If you find methane, then there's gases that are weird gases that shouldn't be in the atmosphere. Just like on Earth, there's oxygen in the atmosphere that comes from life. If you find methane on Mars, we used to say, then that'll be a sign of life. So now we've found methane on Mars, but we're not sure it's a sign of life because there's not much of it and it behaves in weird ways. And there are some just chemical, geological reactions that can make methane inside the Earth, or inside a planet. But most of the methane in Earth's atmosphere does come from bugs, from life.
Just to clarify, we're talking about space farts, right?
Yes.
Yes.
Okay.
That's right.
And burps.
It could be propulsion. See, methane would be great propulsion for us. That's why it's very
if we could use the methane to get back to Earth.
There you go, gas station. We have that first gas station on Mars.
First gas station. How cute.
Is it going to have like a mini mart and stuff? I guess we'll have to set that up. But imagine this, everybody. You land the right spacecraft on Mars, and you use the chemistry of the rocks and the atmosphere to make rocket fuel.
There you go.
To fly back. I mean, that is an extraordinary idea and very cool. And we will talk about that coming up in the next segment. You've been listening to Star Talk Radio. We'll be back right after this.
Thank you.
Welcome back to Star Talk Live. We're at the Convention Center in Washington, D.C., and I am joined by this fabulous panel, which includes our beloved Eugene Mirman, Kondabolu, Joe Firestone, David Grinspoon, and second in command at NASA, David Newman. So, when we left, we were talking about life on Mars. We're talking about what we'd be looking for on Mars. How would we know whether or not we found something alive on Mars? What exactly are we looking for?
Well, it's a puzzle, right? Because we don't know if there's any life beyond Earth. And
by the way, what is life?
Yeah,
man?
well, that's the puzzle. How do we define it when we only have one example? You think there's all this biodiversity on Earth, but we know one thing we've learned for sure is that it's all related. So there's one example of life.
How do we know it's all related?
Well, chemically, of course, it all uses DNA and proteins, and even better than that, by looking at the sequences of DNA and proteins, you can tell what's related to what. And you can make this tree of life, and we go all the way back, and we do not find any organisms that we're not obviously related to on a biochemical level.
Even my
snails?
Old boss?
Yeah.
Even snails are your distant cousins.
Yeah.
You and an escargot are just, a few generations
garlic
removed.
away from being the same.
So we can't really define something that we only have one example of. It's not very scientific. You want a bunch of examples of something to say what it all has in common. And yet we want to search for life elsewhere, so we have these sort of provisional definitions. We think we know what its signs will be. We think we know what it is. But in order to really know what it is, we have to find it and then be able to compare it.
What would you speculate it would be?
Well,
what would it take?
Present life and past life. Right now on Mars, we really think that it's past life, but we say when you look for life, the search for life, follow the water. That's kind of rule number one, follow the water. Now we have water on Mars.
Why do you say follow the water?
Well, because David was saying, we're kind of looking for carbon-based life. That's what we know. Kind of carbon-based life forms, that's how life is on Earth. Now, there could be something we haven't thought of, but right now we're saying, go for the water. We have water on Mars. Mars has a carbon dioxide atmosphere. Pretty cool.
Yeah, I mean, when we're talking about Mars, we're following
We're going to make
the water.
oxygen there.
If we're talking about just life in the universe, looking at exoplanets and such as well, we tend to take a more general view of thinking, well, life, at least we know, is something that perturbs its environment chemically.
Sorry, what are, you said exoplanets?
Planets around other stars.
Oh,
you know how many we have?
Which now we know.
They're super cool.
Now we know. We didn't know this 20 years ago. This is one of the revolutions of our time, is now that we know that all the stars in the sky, almost all of them have planets, multiple planets.
So when I was in school, Joe, people speculated that there might be a planet around 1 in every 100 stars. Now it's generally agreed in sort of orders of magnitude, factors of 10, that every star has at least 10 planets, about 10 planets. And then if you want to get in the argument about Pluto, Sedna, Eris, and these other very distant icy worlds, then you're talking about hundreds of planets.
Thousands. We just let out. We just categorized and let out 1,200 new exoplanets.
But let me just say, just a doggone
looking for
minute.
life on those. It would be great if we could detect water, but even if we just see weird chemistry in the atmosphere,
so Mars has carbon dioxide atmosphere?
Yeah.
And then we can turn that into oxygen.
We're going to do that on our Mars 2020 rover.
Nice. Can I have some of that oxygen?
You have to go
It won't
there.
be enough for a person, but we're going to make oxygen on a planet for the first time ever.
People, hang on, just a minute. Dava, you said, well, we're going to look for life that was once there on Mars. We were back there, back in the old... Look, there's methane on Mars, people.
I know.
We have the MAVEN, what's that? Mars Atmospheric Volatile Emissions, what's the N?
Atmospheric Volatiles Environmental.
Yeah, I think it's Nancy.
Yeah, we think it's Nancy.
Nancy, and she's fabulous.
She's fabulous.
But anyway, if they're finding methane, there's got to be a source of it. I'll give all of you chemists, and I love you all out there, there's some inorganic chemical process that produces methane, right? But everywhere on Earth, we find water, we find living things. Even the tiniest dampness of nothing damp in Death Valley, there are cyanobacteria that live the blue-green things that live under the rocks. Rains once every couple years, and something's alive there, right? All right, so if we're finding methane on Mars with, the Tracegrass Orbiter is out there, and MAVEN, And we're finding liquid water in these recurring slope lineae, right? And the geologists love the
Seasonal,
Latin.
yeah, exactly, seasonal.
So it's a little rivulet, a little rill, a little drip of water
and lots of
every
ice
year.
on the poles.
Hari, I like it. You can't see it on the podcast, people, but he is inquisitive man.
Oh,
He's hanging on this.
Like, how much water are we talking about right now?
Right now, just a small amount. Briny, salty water. You don't want to drink it yet. But the great thing is we knew there's ice. There's ice on the poles. But now this is...
Almost none on the surface.
Yeah, and this is seasonal. So when, it's seasonal, but, so we have
But
seasons.
look, every Martian summer, there's a little
it's
waterfall.
Cool. It's fantastic. I'm
Okay,
with you,
that's
Bill.
not nothing.
I am with you.
Wait,
It's
Rana,
really
are you making that's true?
I am with you.
That's not a thing you just lied about? That's
No,
a truth?
not about that.
Oh.
No.
It's true.
It's a Martian waterfall.
Well, or rivulet.
Rivulets. I like rivulets better.
But there's a lot of water
seasonal
underground.
Water. Yeah.
We believe. We know,
So,
actually.
you guys,
There's
I am
water on Mars.
open-minded, of course. But you're telling me that we've got liquid water on Mars. And we have methane that we detect, albeit in strange ways, from billions of kilometers away with these extraordinary spacecraft. All right. And you are not optimistic about finding something
completely
still
optimistic.
alive?
And I think it's going to be sooner than later.
I'm not. I don't think there's life on Mars today.
By life, do we mean something?
And I think, actually, that's a good thing. I'm optimistic that there's no life on Mars today, because that makes it much less complicated for us to do the things we were talking about earlier and not be wiping out
Okay,
the
just a
biosphere.
minute, European immigrant man.
Yes.
It sounds like you might be saying, well, I'm pretty sure there's nothing alive there. We're not going to contaminate it.
Not
Let's
really.
just show up.
No, because I very much support our carefully investigating this question. I think that right now our ignorance vastly outweighs our knowledge. But I am a skeptic as far as the methane we've seen and the water we've seen indicating a biosphere.
Why are you skeptical of that?
Because I think that on a planet like Earth, you look at, if you were an alien
here,
for instance, this room, if you were an alien looking at our solar system from afar, there'd be this planet Earth that has a flagrant biosignatures. This oxygen is off the charts.
Flagrant. You people are flagrantly signing your bio-ness.
I don't think a planet like Mars that has very subtle potential biosignatures will ever be alive, because on a planet like Earth, the biosphere is coupled to the active biogeochemical
For those of you watching the
cycle.
podcast, his arms are
I'm
just
waving
waves.
my arms.
He's making
Because Earth has
snow angels in the sky.
Earth has this active hydrological cycle with rainfall and evaporation. It has plate tectonics. The geology is alive. The chemistry of the interior is in communication with the atmosphere.
He's still waving his arms.
I'm waving my arms.
But it's
And on
Earth
Earth,
now become modern dance.
on Earth, life.
But do
He's
you
out
think
of his
there's
chair to get
do you
the
think
arms.
there's like microbes in the water and like
That's what I
guess that
think.
there aren't like
What I'm
squirrels?
saying is that on Earth, life rides the cycles of an active geological planet. Mars, in that sense, is a pretty dead planet. I think, as David was saying, we will probably find signs of life in the past when Mars was a less dead planet. But if I had to bet, I would bet that Mars does not have life today.
And we're
So
including
speaking of
microbes.
betting, speaking of betting, they won't take the bet now.
I'll bet $1 and we'll figure it out in what, 2032? So,
I say I would go with 2033.
Okay, 2033 it is.
And we'll be there. We'll be
Is that
there.
where-
friendly.
so
Our
when do you
rovers
think
are
we'll
there.
be on Mars? You're the most
Well, we are on
qualified.
Mars today with 5 vehicles in orbit and
Sorry, with like
surface.
a group of kids playing soccer.
Group of kids playing Mars generation, the 2030s.
So let's back up to the disco era.
My favorite time.
Yeah, good. You're in the right place. So the Viking landers had these scoops. This was in 1976, July 4th, coincidence, 200th anniversary of the United States. Viking 1 lands there, has a scoop akin to an ice cream shovel, and scrapes into the soil and stuff. Then it drops some of that soil into some chemistry experiments that were spacecraft style. You can't see them from here, but the scoops dropped the dust in there, and something happened, right? And people, for a couple days, for those of you who were not around in the disco era, there were a few days or even weeks when people around the world totally freaked because it seemed like something was bubbling on Mars that might be alive, right? Now, can you comment on that thing?
Well,
what happened there?
This gets back to this vexing question of how do we look for life when we really don't know anything about life elsewhere? And the Viking biological experiments were a wonderful set of investigations, but in hindsight, they were maybe a little bit naive in that what we were really...
What did they really do, really?
They were looking for life on Mars that was very much like life on Earth. Essentially, they scooped up stuff, like you said, and they sprinkled it with what they called chicken soup, which was
right now, it's
water
like
and
rock,
nutrients.
scissors, papers. His fist has gone into his hand.
Yes.
Wait.
They sprinkled up stuff. They put it in this experimental apparatus, and basically they sprinkled it with water and what the scientists nicknamed chicken soup, which was a set of nutrients which Earth organisms would have loved, simple organic compounds, and they looked to see if anything happened, and did it give off gases where the carbon...
Which it would if you put a scoop of earth soil.
And they even labeled the carbon with radioactive carbon heavy, isotopically heavy carbon, so you can see if the carbon in the chicken soup...
You can see if you have the right instrument.
Yeah. You can, with that instrument, you could tell that the carbon in the chicken soup was the same carbon that came out. It was as if the stuff was breathing out carbon dioxide. So they said, aha, there's something in there that's eating chicken soup and breathing out carbon dioxide. It's alive. But then it didn't really behave like living organisms. There was a big fizz of this carbon dioxide, and then it went, psh, it tailed off as if it was more of a chemical reaction.
For those of you listening, his hand went way up, like he was going to do a hook shot, and then it came down like he was going to... An
exponential decline.
Exponential
I feel like it would help the
decline.
listeners if you just picture one of those things outside car washes.
Yeah.
You know, like every time. I feel like that's a great visual.
Oh, the inflatable guy that flops around.
Yeah. Mm-hmm.
Yeah, that's David. There you go.
It first looked like it was behaving like life. It breathed all this stuff out, and then it looked more like Pop Rocks or something, where something fizzes, or Mentos and Pepsi, where something fizzes all of a sudden and then just dies off. If it was organisms, it would sort of perpetuate longer. So it ultimately had a shape over time where it acted like some chemical in there was really excited to react with the stuff we gave it.
It wasn't Pop Rocks to Mars, and Pop Rocks were like, we're Pop Rocks.
Exactly.
But they didn't find life.
So it fizzed, but it didn't really metabolize, unfortunately.
That's the way we would understand it.
Now, one should say there are still some holdouts. There's this guy named Gil Levin, who was one of the original investigators on this. He's still alive, and he's a smart guy. And he thinks that they found life on Mars with this experiment. And he refuses to be convinced otherwise. And he's a smart guy, and there's still a little controversy about this. Is an indication of the fact that we don't completely know what we're doing when we're looking for life, which is kind of what's exciting about this. We're on the edge of our knowledge, and we're trying to investigate something that we can't completely grasp.
So Mars is crazy cold.
Yeah.
Venus is crazy hot.
We're the classic Goldilocks story.
Exactly, that's the word we use. We are the Goldilocks planet. You've convergence of a great scientific mind right here. Way to go.
We got the porridge that's the right temperature to eat.
That's what we've got.
Earth is the right temperature to eat. Gobble, gobble.
It is. No, it really is.
It's a beautiful planet.
Don't tell Galactus.
But isn't there... Okay, listen, my mind is sort of blown from this
exoplanets, yeah.
It does seem like gossip girl. Okay, but listen, so exoplanets, there must be around those stars a planet that's equidistant from those stars to Earth. What's happening?
I know, so that's it. So we have an instrument, and the James Webb Space Telescope's coming up. Kepler's out there now, but this telescope is going to look with such sensitivity. How sensitive will it be? That people believe they'll be able to look through the atmosphere of a planet backlit by its star. Are you digging me? Sunlight from a star is going to go through this planet's atmosphere, and this telescope out in space will be able to detect what gases are in that atmosphere. And what everybody's all hot for is water vapor and methane, the natural gas, the stuff in the blue flame of your stove.
And oxygen.
And oxygen. This would be like so cool. And so my claim, everybody, is these discoveries, if we were able to discover life on Mars, on Europa, the moon of Jupiter, with twice as much seawater as the Earth, at least.
Twice as much seawater as what?
as the Earth.
All of Earth.
Oh, really?
Europa has.
And maybe even a little more than twice as much.
Great place to go look for.
Oh, wow.
life.
Does Kevin Costner know? He'd love it.
Don't tell him.
So anyway, what we want to do, my claim is if we were to find life on one of these places, it would change this world. So let's say we were going to go do this. David, at Dr. Funky Spoon, man.
Sir.
What is your dream scenario? Finding life on Mars. How would you go about doing it?
Well, I think that we're going about it the right way. I would love to accelerate. If my dream scenario would be that, we double or triple the NASA budget for exploration and could do more. I think we know what to do. Thank you.
By the way, let me just say...
More sandwiches. Who wants more sandwiches?
Yes.
For instance,
let me just say, as CEO of the Planetary Society, I spent a lot of time on this stuff, and we've gotten the planetary science budget now up to about 1.7 billion, which I know doesn't sound like much. But everybody, the NASA budget is about 0.4% of the federal budget.
Yes, 0.4, right.
Yeah.
How do we get it to say 2%?
Well, so in the Apollo days, it was 10 times that. It was 4% of the federal budget. And so the planetary science line item within the NASA budget is less than 10% of the NASA budget, 9+%.
We do a lot.
And so these were the extraordinary discoveries are made. So your dream scenario starts with getting more money.
Yeah. So,
and then where do we go from there?
My dream scenario for Mars, specifically, is, as I said, I think we're going to confirm that there's no life on Mars today. But I want to be really sure before we go and do other things there. So we got to check out this methane, figure out where it's coming from. If it's not life, it's telling us something really interesting about the geochemistry of Mars that we need to know. But my dream scenario for Mars, as Dava mentioned, the possibility of finding fossils. There should have been life on early Mars, given what we know. We'll either find fossil signs of life on Mars, or if we study Mars really carefully and understand those early environments and find that there was no life ever on Mars, that is also a really exciting thing to find. It tells us something about Earth, that there's something special we don't understand.
Everything we learn about stuff in outer space informs what we know about the Earth. And I claim that the more we know about our solar system and other solar systems with other stars and exoplanets, Joe, the more it informs ourselves and where we all came from. This is the two deep questions. Are we alone in the universe? Just here's the big question, though. What would we do with life if we found it? And we're going to talk about that when Star Talk Live comes back right after this.
We'd like to give a Patreon shout out to the following Patreon patrons: Justin Adamson and Forrest Shepard. Thank you guys for your support, because without you, it'd be very difficult to do what we do. And if anyone else would like their very own Patreon shout out, make sure that you go to patreon.com/StarTalkRadio and support us.
Welcome back to Star Talk Live here in Washington, D.C. I'm here on the fabulous panel with Joe Firestone, Dr. David Grinspoon, Dr. David Newman, Hari Kondabolu, and our beloved Eugene Mirman. So we're having nothing but fun here on Star Talk this week. We're talking about life on other worlds. We're talking about space science superheroes. And this segued into this search for life. And now we're talking about how we would actually go looking for life. We have some assets there on Mars right now, right? We have the Curiosity rover. We have a lot of assets in orbit around Mars. And the idea, let me just start by going back to start with. Why are we all so hot to look for life on Mars? Why not life on Mercury or Venus
close by, Mars is the best place to look for life. And then we get further out into the solar system, and then we go to these ocean worlds, which even look, better. But again, Earth and Mars really are sister planets.
And it looks like Mars was once wet,
and now
Mars
was wet.
it's the most Earth-like environment on the surface of another planet that we know of. And we have a lot of evidence that in the past it was much more Earth-like. So,
do we have a sense of why it's so sad there now?
Yes. It's not as big as the Earth, so it cooled off faster. So it does not have the churning iron in the middle that we have on Earth, creating a magnetic field, which makes the solar wind particles go downhill when they get to the North and South Pole. But on Mars, apparently, these same particles scrape the atmosphere off, scraped it into space.
So it lost its atmosphere. It ablated. We can see it. It's still going on today. Our MAVEN spacecraft is in orbit. Check out,
and you can see the atmosphere.
We can see the ions ablating. It's only a 1% atmosphere. Mars has a 1% compared to Earth. 100% here has 1% in its carbon dioxide.
Yeah.
So we see it's not protected by that magnetic shield.
Water.
Is there any way to put an atmosphere back on?
So hang on. How are we going to get there, you guys? We just had a humans orbiting Mars workshop. The Planetary Society pitched a humans orbiting Mars architecture, as it's called. And along with all the many things NASA was going to do was develop these solar electric propulsion spacecraft. And how does that work? And the solar electric was going to go out to an asteroid, the asteroid redirect retrieval mission, right? How does solar electric propulsion work, and how is it part of going to Mars?
Right, so when we go to deep space, get back Earth, Moon, cislunar, right? That's the next step. That's phase 2. First on space station, low Earth orbit. This 2020s will be on our Space Launch System. That's our heavy lift launch.
Space Launch System is a NASA word for big rocket.
Big rocket. Big rocket. We haven't had one like this for 40 years. Move over Saturn V. It's more powerful.
More powerful than a Saturn V.
Now, these rockets, these are made of your standard metals. Your tins, your
standard.
That's a great question, Joe.
Yeah, using aluminums, using additive manufacturing though to make it's much more efficient. So we're using high tech but big rockets.
But we're basically using Home Depot stuff. We're using the screws and the...
Yes, nice stuff. Though.
Yeah, nice, high-end.
Yeah, you got to go to that aisle way at the
fanciest
end.
Home Depot you can and double it.
Right. And then we get out to cislunar. So now we're in deep space, okay? We're in deep space. Not quite yet to Mars yet. That's phase 3. But in phase 2, we're into deep space, and we have to demonstrate some technologies. Because you don't just get to Mars in one leap.
No, but here, let me just tie this in.
Space electric propulsion. You want to know, in-space propulsion.
But here's the thing,
electric.
as Joe just said, Home Depot-style rockets, chemical rockets. Is what you know what I mean, Joe? You got a liquid oxygen, you got some other fuel, you mix them with a fuse, and they burn like crazy, and they make that cool noise, and then they go into space.
The shh.
But it's usually...
Really?
And then what happens after that?
Then you're in space, and there's some reason you don't want to use chemical rockets anymore, and that is?
Well, we need breakthrough technologies as well. We need new technologies. So what we're investing in now we're getting to the moon, right? So your deep space, our top technologies we're investing in today.
But isn't it that
in-space propulsion?
It's hard to carry all that much fuel,
It's hard to carry cargo and fuel. It's got a gravity well. In-space propulsion, so there's different ones. But so we're talking about solar electric propulsion. That can move big cargo, lots of mass, heavy mass, goes slowly, but that's all right. We'll get there. So it moves a lot of cargo. You're going on a camping trip.
We're rockets in space.
Yeah, we're more than 17,500 miles per hour, but still slow for space. Slow for space
how fast
speed.
Is fast for space for us?
Well, light speed is fast, right?
Yes.
Yeah,
sorry, but meaning
Joe.
When you say slow, you mean as fast as we can make. Not like we're...
Slower, let's say, a little bit, slower, because you want to get your people there as quickly as possible. So big rocket, let's go fast. About 8 months, That's fast for us. Punch it. 8-month trip, because we got to get boots on Mars. We get in orbit. But this in-space propulsion, solar electric, that's a nice candidate. Constant acceleration, so just keep going all the way. Let's carry your groceries, carry the stuff you need with us. We always bring a lot of stuff.
Does it arrive later after the people?
Well, we can be popping them off, right? So if we get this capability.
What we want to do is have stuff in place before humans show up. You want to land some tents.
And fuel depot, as we said, habitats, so that's what we're investing in.
I just want to talk for a second about the rocket equation. Who doesn't?
Oh, I love the rocket equation.
Yeah, so the big thing that makes a rocket go, and you've seen this, Joe, is the stuff coming out the back is going really fast.
The classic orange in the child's drawing.
Yes.
Yeah. Afterburners, that's it.
Yeah.
The orange.
So it's going really fast out the back, but you need a lot of fuel, and you reach a point where you can't get the rocket going too much faster because you can't get the exhaust going that much faster.
Yeah,
right?
That's called specific impulse. So that's what we call it in the rocket equation.
So in solar electric propulsion, we're going to take a big tank of xenon. Is that right? For example. Yeah. So anyway, you get a tank of this stuff liquefied, and you get it by getting the atmosphere, getting a big tank of air on Earth cold, and the xenon separates out in a layer like a parfait, and then they extract it, put it in a tank, and then they put it on this rocket.
Sounds delicious.
Yeah. Oh yeah, it's nothing better. Stuff. Well, you breathe it all the time in tiny amounts, and look, I've been doing it my whole life, and I'm fine. No, so then you have solar panels. Is this right, Dava?
Yes,
and
so
they
far,
make
so
electricity.
Good. They need electricity.
Then we have
power.
a window screen-looking thing, and it electrically attracts the xenon from its little tank and shoots it out the back at super fast speeds, right?
Yep.
And that's really an ion drive,
really ion
like
propulsion.
in science fiction. But anyway, the solar electric propulsion idea is going to be used to go to Mars, right? Now, what are we going to do with that?
We're counting on it. Solar electric propulsion, we're counting on that. Let me tell you a few other ones we're investing in right now. Deep space habitats. Incredible, public, private, again. Industry's working with us, deep space habs. We're sending people, we got to figure out
deep space habs?
Life support systems. You got to figure out to get, we're going way beyond low Earth orbit. So we need deep space habs. Bigelow's beam just inflated, expanded this week on Space Station.
Is an acronym.
Yeah, for the Bigelow Expandable Module on
so
Space
it's a balloon.
Station.
A nice one.
Expandable habitat.
It's a big inflatable thing attached to the International Space. You got me doing it with the hands.
But not too big. Space Station is big, a football field size, right? These are smaller halves. We need to test them out. Now, number one, radiation. What about radiation protection?
What about radiation? Years ago,
serious.
people said if you tried to go from the Earth to Mars, the radiation would kill you. But now people have rethought that, right?
It is a problem. The radiation is one of the serious physical problems with sending people to Mars. And we know a lot more about this now because of the Mars Science Laboratory, which is our Curiosity rover, which is on Mars now doing wonderful things. But on the trip to Mars, this instrument called RAD, the Radiation Assessment Detector.
Radiation Assessment Detector.
Yeah, and I'm actually a co-investigator on that instrument, so it's near and dear to my heart. I'm a co-I on the RAD team. And one of the things that was cool we were able to do with RAD, it was designed to measure the level of high-energy radiation on the surface of Mars, on the rover, which it's doing in a wonderful way. But we realized that we could also turn it on before we got to Mars. It's the one instrument on the rover that we turned on while it was still in the spacecraft on the trip to Mars, because it allowed us to measure the amount of radiation in interplanetary space and basically simulate what a human would experience in terms of radiation on the way to Mars. And so it's the first time we ever did that, and now we really know much more than we did before this mission.
Will it kill you or not?
It will not kill you, but it will put you at greater risk of getting cancer, which could ultimately kill you. But it's not like just going to Mars is going to fry you and you'll be dead when you get there. But it will by a few percentage points.
You'll die when you get back to Earth.
Well, it's equivalent to you go to the doctor and you get like a CAT scan.
Yeah.
If you do that,
getting an 8-month CAT scan.
If you do that a lot, you're slightly increasing your chances. So you don't want to do that all the time.
Chances of getting cancer.
So your life, for
it's
radiation.
As if you did that once a week.
And we look at total life dose, total life radiation dose, and we're going to protect the astronauts. That's what we're mapping. We're taking this data. Now we're looking at the Mars radiation environment, and then it's our job. How can we protect the people? How can we protect the spacecraft? Don't want to fry your instruments either.
Plus,
so we protect the people, and we have some interesting ways to do that.
The kind of people that want to be astronauts, If you say, well, you got an extra 1% chance of getting cancer, I'm in, I'm going, man.
They say yes.
But you still want to protect them.
Absolutely.
So what are some of the ways that we...
Is it similar to like when you go to the dentist and they take pictures of your mouth, they put the thing over your...
There you go.
It's that kind of
That's
thing.
the shielding. So high density is very good for shielding, especially for, galactic cosmic radiation that we're gonna see on Mars.
Created the Fantastic Four, for instance.
Right. But when we're in this space, there you go, superheroes. But in the craft, water, because we like water to drink, it's pretty high density.
Yes,
it actually
I'm
is
a big fan.
Yeah, it's a pretty good radiation shield. So there's interesting concepts in the vehicle, high density materials. We're going to take water anyhow. It'd be nice to kind of live in the water walls. That'll really help the astronauts.
And does it harm the water for it to be radiated for you to drink it?
No, the water doesn't care at all.
Meaning the water doesn't care, but when you drink it, it doesn't matter to you.
No.
You're okay.
That's a great
Most of it passes right through.
If anything, if there were any little bugs in the water that you didn't want there to be, it would make
kill
it
it.
nice and clean.
Yeah.
So you'd have a jacket, you'd have a ball, a sphere, a shell of water around your spacecraft.
Like a water bed.
A water bed.
Like a water bed to space.
It's a good concept.
Great MTV Cribs.
When we get to Mars, don't want to put it in the suit because you want to be mobile, lightweight, but lava tubes and there's a lot, volcanic. So where are we going to hide? Where are we going to live?
Yeah,
underground, caves, things like that. These are all actually amazing shields.
So hang on,
Is there space underwear? Has that been discussed? Like, what are the sexual side effects of radiation? I'm just getting to the question I'm sure you were all considering from the get-go. Like, what happens... is there extra protection in those areas?
How is Scott Kelly's long-distance relationship?
I'm sure he asked that question.
Yes.
There was no way he wasn't asking that question.
I think if you're going to have children,
do it before you go to Mars,
or at least put some in the freezer. You know what I'm saying?
That makes sense.
No, that's a good idea.
Or have one before and then have one after and see if the second one's a mutant.
That's the scientific approach.
I think here at AwesomeCon, let me rephrase that, a friendly amendment, if the second one has superpowers. Because that's what you get. If you're a superhero, a lot of times you were irradiated. Maybe you were bitten by a radioactive spider. I don't have to tell you.
Maybe what's been irradiated is just your father's ding-dong.
I like how you used the scientific term for penis.
I'm a gentleman.
So just as far as I know, ding dong is not an acronym. It's
No, it's just the thing it is.
So
when you say ding dong, I'm looking over at the interpreter here and just wondering what.
Yeah.
But anyways.
Or if you're a lady, you're doodle.
Let her explain.
That was so worth it.
That was good. That was good. She explained.
Where were we?
Where were we? We were in a couple of places. We're on our way to Mars.
We're on our way to Mars.
Now, you mentioned the radiation detection instrument. What other instruments would you take? Why would you take them? And then fundamentally, everybody, would you go to Mars if you had a chance to go to Mars? What instruments would you take?
If I was going to Mars?
Or what are you going to send? What are you going to do?
The thing that I most want to do if I were going to go to Mars is look for fossils.
Fossil life. These would be bacteria in a mat.
I would take rock hammers and drills and a microscope. A scanning electronic microscope if I can get away with making one small enough. To
carry there. Because right now, scanning electron microscopes are big...
but one thing that NASA's
massive.
really good at is making things small when we need to and put a little technology development into it. I would want, on my Mars laboratory with my astronauts there, I would want to be able to go out and drill and find samples in the most promising sites.
Bring it back.
And I want to look for the isotopes, so I'd want a really good mass spectrometer to look for isotopic signs of life, for signs that life had altered the chemicals in the past, and I would really want to look actually for physical fossils and the right kinds of deposits.
Let me say, my father was a rock hound, like the rocks. Every rock tells a story. My uncle was a geologist. And the way you're describing this to me, David, is geology tools.
Yes.
But what non-geologic instruments would you take?
Oh, I thought so. Well, first, we're taking the people. That's what I'm about. We're taking the people and our rovers and machines, because that's how we work better. We will explore 100 times more of Mars if we get there and we're mobile and we're working in teams, people.
I've heard this said that what our best rovers do in a week, a human would do in less than 5 minutes, maybe even less than a minute.
So it's order of magnitude. We're much more, mobile and quicker. So we're all in this together. And what other instruments?
Our robots and our people.
Our robots and people. It's
well,
just
what
a
instruments
team.
Would you take?
What other instruments? Well, actually, back to life support systems and bioregeneratives. I actually would make sure I could make oxygen, bring it, make
once
oxygen.
You start on that.
And water, things like that. There's not enough there for us yet. So I'm kind of worried about staying alive. So I'd like some water, like some oxygen to breathe.
Let's say you got that problem solved.
But Bill, it's funny the way you phrase the question, non-geological instruments, because the word geological has geo, which means Earth. So any of these instruments on Mars
let me rephrase it.
Areological, right? They're which Ares is Mars, and anyways.
I was going to say that as well.
Okay.
So if we want to understand the ancient story of Mars, then we're going to apply a lot of the same tools we use to understand the ancient rocks and the ancient story of Earth. So we look at ancient sediments because they're what capture the atmosphere too, the bubbles, bubbles of air.
Okay, but hang on a sec. The Viking missions had some chemistry thing that everybody got excited about, right? Because
that was wrong, though, right?
Well, one guy says maybe not so wrong.
Okay.
So that was a biology experiment.
Yeah.
That was the spiritual equivalent of a petri dish.
Sure.
Right. So what is the spiritual equivalent of let's say Mark Watney has it all figured out. He can breathe and grow potatoes and whatever he's going to do to take care of himself. How is he going to find, or she going to find, evidence of life on Mars? What instruments do we need?
Okay, we'll do the instruments, but let me tell you, I want to say, who are the people? Because you asked about, is it the astrobiologist? I hope not. I hope it's not a single discipline of anyone, because we need, a whole new education. So this is, point. You need know a little astrobiology, right? You want to know your geology? I'm thinking an MD might be, little medical knowledge. So we really need cross-disciplinary trained folks. So I hope it's not just an astrobiologist.
But what you just described is astrobiology, because astrobiology is a sort of polydiscipline. If you go to an astrobiology meeting, there's people talking about geology, people talking about astronomy, chemistry, glaciology, philosophy.
But not botany, so you do need a few different people.
Well,
a few different people.
Too.
But I'm all about STEAmed. I'm all about STEAmed. We need
agree
the
with
STEM
what you're
fields,
saying,
but the artists have to be there, the designers, we're all in. We need everyone.
Also psychics.
Yes.
Psychics. Comedians, you're going to need some laughs. This is a psychosocial.
Yes.
This is a tough trip.
But if we really think we're looking for extant life, then we want to bring, petri dishes, and we want to try to culture stuff.
That's what I'm
saying.
saying.
What are you going to use for your agar in your petri dish? You don't know what Martian bugs like, so you got to get very clever there. And that's why I'm drawn more towards microscopes and things where you don't necessarily assume too much about what that stuff is doing chemically. You just want to see if there's a bug, you're going to recognize it.
The geologists all want to bring back samples. They're crazy for it. And if you take a geology course, you get a rock hammer, you go to the rocks and you knock them open and you bring them back to your dorm room, and your friends think you're having issues. And they want to bring back a sample. It'll be 3 steps. 2020 rover drills into the soil, picks them up. 2022 flies them up into Martian orbit. Then 2024 or 5 brings them back to the International Space Station, and we open them up and take a meeting, right?
Take a meeting.
But is there any concern that we're going to bring back the Martian microbes of death? What are you going to do about that?
There's a slight concern, but I would say very, very slight.
Very slight. Is it worth the risk, Mr. Bond?
Yes, because here's the thing. You can't explore with zero risk. If we wanted to be perfectly safe, we would never bring back a rock from Mars. If you wanted to be perfectly safe, you would never leave the house in the morning, right? So anything interesting involves a certain amount of risk. But we're not going to...
befriending scorpions.
Yeah, exactly. There could be nasty things, but this is why we're doing the precursor missions, and this is also why we have protocols. If we do bring back a sample of Mars, there are requirements to keep it very carefully isolated and
like Area 51.
Even, there's like Area 52, man. You haven't even heard of it. It's really secure.
So you guys, I just want to thank you all. This has really been a cool discussion. Everybody had these terrific insights asking these fundamental questions about the nature of life on another world. How would we find it? What would it be like? How would it affect us? How are we going to get there? Even how are we going to pay for it? We talked about all of this. This has been like the greatest Star Talk Live ever. Give everybody a hand. This has been a great panel. Joe, David, Dava, Hari, and Eugene. I've been Bill Nye, your host. This has been Star Talk Live. Thank you all so much. Thank you.